Hi, my name is Jason Blanchard. I'm the Content Community Director here at Black Hills Information Security. Thank you so much for joining us today. Today we have Tim Fowler who's going to talk about offensive Windows event logs. He's already given this talk once and believes he can do it in the hour that we have. We will have Q&A at the end or during it in case there's a lot of questions about a thing. But if you want to ask questions in Discord because your fellow attendees might be able to answer them, that would be amazing. We'll drop the link to Discord here. You can always join us there. But if you want to ask questions in Zoom, you totally can. Tim, are you ready?
Let's do it.
All right. If you ever need a threat hunt or red team or pen test or ATT&CK, you know where to find us. Tim, it's all yours.
So let's get started. Hopefully you are here for offensive Windows event logs. I did have, as Jason indicated, I did have the pleasure of doing this, a version of this talk at BHIS Atlanta just a couple of weeks ago, but I'm really excited to be able to share it with you guys. To get started, I want to kind of ask this quite general question, but there's two parts to it. So the first thing is, what is lurking in your event logs? From a blue team perspective, we use event logs often to correlate activities that are taking place on a system. They're typically retroactive. But on a red team, we typically don't leverage logs. We don't really, the whole goal is maybe to not generate logs. So we're definitely not taking advantage of this. And this is a little bit of we're going to look at kind of a little bit of a blind spot within the Windows ecosystems. And as we go through this, I want you to just kind of think about some ideas, both from the red and the blue side. Blue team, what do you think you could do to prevent, detect, or alert on some of the activity that we're going to be showing? And red teams, what are some ways that we can take this capability and kind of leverage it even further beyond what we're going to show today? But I do want to set a couple of expectations. We are going to be talking about red team offensive capabilities, specifically in persistence, but there's some things that I don't want you to expect because for two parts. One, they're not needed. And two, I am not well versed enough in these, especially in areas of obfuscation, defender bypasses, evasions of endpoint detection, stuff like that. We've got rock stars here at BHIS. I just lean on them when I need to leverage any of this capability. But you're not going to see any of this. But we may talk about a little bit why you want to see this. So to understand kind of the genesis of this, back on May 4th of this year, I was actually out in San Diego for Way West. John Strand sent an article to our testers channel and teams, and it was from Threat Post. And that article then referenced this report from Kaspersky talking about this new fileless malware. You know, everybody loves the term fileless and stuff. And if it came from John, so naturally I looked at it because I found it probably relevant or interesting. But there something about it just kind of caught my eye, and I'm like, this is really cool. This is something I want to kind of look at and investigate a little bit further. And so I did. And the crux of it is that Kaspersky had identified a threat actor in the wild that was using event logs for payload storage. And I'm like, that's really cool. And I started asking, why is that working? How is that working? And kind of things. And so this was the genesis of everything that we're going to talk about from here. Looking at some of the details from this report, there was a couple of things that just immediately stood out to me as not understanding why they may have taken this approach. And it was just really cool. The fact that they were using this for persistence. Kaspersky classified this as a late stage persistence mechanism. The fact that they were hiding shellcode in Windows event logs was cool. They were using key management service, which was an event log that I really wasn't very familiar with. And also they were chunking their shellcode in 8 kilobyte chunks. And there was some reasons for that we'll get into just a little bit. But to understand where we're headed, we do have to do a little bit of background, unfortunately, on some of the basics of Windows event logs. Most of us probably have a rudimentary understanding, but when I was going through this process, there was some things that I learned, and there were some things that I needed to kind of understand how the mechanisms worked, to understand what the restraints were and the requirements for making all of this work effectively. So just to start off, Windows event log is essentially, it is a structured data format that records the events that happens on a system, whether it's software, hardware, the operating system as a whole. And the structured format is put into logs. And as we say, the most common way for looking or analyzing logs is we'll use the event viewer. And so I would think most everybody on this webcast is familiar with this view here. But we're going to get into some of the specifics. First, over here on the left side, we have our log names. These log names are actually registered in the Windows registry as keys. And we're most familiar with like application, security, system, those things like that. But there's one that was not common to me, or I hadn't really paid attention, was the key management service one, which was referenced in Kaspersky. And this is where those logs actually sit. The other thing that we have is a source. A source, you may also see it referred to as a provider, but effectively what it is the application or the service or whatever. It is the component that is recording the log entry. And so this is going to come back and be very important here very shortly. Event IDs, we all know what event IDs, we know what various ones mean in various contexts and things like that. From a blue team perspective, event IDs are going to be very important in terms of what logs are we going to alert on, what are we going to forward, because not many organizations can afford to potentially lift all of their endpoint logs up. And so you have to be selective and things like that. So event IDs will come into play as well. And there's a few others that we'll get into. But as I said just a moment ago, those event logs are actually a key within the registry. So if you go into regedit and look at your registry, if you go into HKey local machine system, current control set, services, event logs, you will see all of those registered event logs right there. With those event logs, each of those registrations, you have then what's called sources or providers. I'm going to most likely refer to them as sources from here on out. And these are the individual registrations or the individual bindings of these sources to a specific log. They are kind of hierarchical in nature in that a source is registered to a specific log. And I don't believe you can have a source of the same name exist to any other log. That might not be 100% correct, but I believe that is. You definitely can't have two sources identical within the same log. So, for example, on the screen, you see the .NET runtime. I can't have two sources that are .NET runtime for obvious reasons. So within the source, we'll drive down one step further into it. So we've got application. We have the source or the log, the source that's generating the entry, and then inside that source we have some information in the registry. And one of the most important things here is every source is supposed to have an entry for the event message file. Now, this can be an executable, this can be a DLL, it possibly could be even a text file, maybe, I don't know. But this is important. This is where the actual messages that pop up in our event viewer are stored. And so when an entry is created, it will reference the event message file based off the event ID and populate the event viewer or the actual log entry with the corresponding message there. And so we see here on the restart manager, which is just a random one that I picked, you have event ID 1000. It corresponds to this message, and that message is contained in that event message file that's specifically the restart manager DLL. The other thing about the messages is you can generate logs or log entries that don't have a corresponding message. So for example, here, I manually created an event entry that for the VSS as a source with an event ID of 1337. When I do that, because the event ID 1337 isn't mapped in that event message file, that DLL that it's referencing, we get this kind of boilerplate text here that says the description for this event and from the source cannot be found, blah, blah, blah. It does include your message, but you do have this boilerplate. In my research, which is not exhaustive, but I did it as much as I could, I never once saw this message outside of me doing something manually, which was kind of interesting because it's if you go with what where we're headed, this could be a potential indicator of compromise, not necessarily a very strong one, but this is something that I just have not found records of in my research just happening naturally, because in most cases, things are done in a well-organized manner, that an event ID that is being registered or that is being logged corresponds with something in the message file. And so I do see some questions going on in Discord. I will try to get back to those at the end. I do apologize. I see them. I'm trying to stay focused and not get too distracted, but we will revisit those at the end. So keep those coming. So one thing that is cool is outside of just the standard sources that are there, we do have the ability to create sources within a given log within certain requirements. It does require us to be local administrator in order to do this, because we are writing to the registry. And so here you can see within the application log, using this PowerShell command here, we're able to create a source called BHIS within the application log. When I do that, it automatically, because no event message file was given to it as part of the creation and invoke instructions there, it auto-populates it by default with this event log messages DLL from the .NET framework. Here again, if someone is, if an operator or red team or any pen tester is creating sources on your system, first of all, you're going to have a registry entry so that's something that's easily trackable, something that you can alert on, because sources do get created, but they're typically with software applications and things like that. So it's not something that's like, you should never have a new source. That's not the case. But it is something that you can at least alert on it, because it is a change to the registry, but also you've got this default event log messages DLL. On the systems that I've looked at, I've only found 2 instances where this file is actually being referenced in the registry for sources. One of them is when I generate one manually. The other one is another one in application, and I can't remember the name of it. So it's not very common. Now, obviously, if you're running a different version of .NET Framework, the exact path will be a little bit different. But as Blue Teamers, this might be something that you could also look for on your systems to see if new sources are being created with this default state or this default message file. It's just going to look a little bit suspicious, at least from my perspective. I wouldn't expect that. Getting a little bit further, now we've got our custom source. It's pretty trivial to actually create an event log entry. And we're going to show a different way in just a moment, but doing it this path, we're using system diagnostics, event log from .NET, and we're just writing an entry using the source of BHIS. We're giving it a message of checkout prompt, and then we're setting the information type the type to information, and we're giving an event ID of 1337. I didn't really talk about the information type or the types for the event log. And when we went through the kind of the breakdown of what all the logs are, and the reason why is because if you're going to use this method, just use information. There are other ones such as error, warning, and things like that, but they have nice yellow icons and red icons and stuff. Information, it's not providing you any really level of security or obfuscation or anything like that. It just blends in a little bit better. It doesn't stand out and stuff like that. So this would be something that you want to potentially look at. Just use information across the board, and that's what I end up doing. And from here on out. So one of the last things that I needed to do was to understand what kind of permissions or restrictions there were around reading, writing event logs and from different user contexts and things like that. Luckily, Microsoft published this lovely chart. It's not exhaustive, but it does cover pretty much everything that I needed to know from the application log, which is what a lot of us are most familiar with. Also, system and security logs. As a local administrator, you can read, write, clear. If you're not aware, every time you clear an event log, it does actually create an entry indicating that the event log was cleared. In our context, you probably don't want to go clearing logs if you can help it. Domain administrators and stuff like that. The one that's missing from this chart, which I thought was a little bit ironic, is the security log. Essentially, I believe only LSAS can write to the security log. And by default, a local administrator can read from the security log, but a standard user can't. The whole point of me looking at this is like, are there basically any constraints that as a basic user, I haven't been able to priv-esc, but I need to get a initial persistence or anything like, is there any kind of restrictions on that? And effectively, if I'm not writing to the, not attempting to write to the system log or security, I'm good. I see incorrect admin can write. Okay. In certain contexts, admin probably can write to the security log, but so thanks for that clarification, Cactus. So now what? We've gone through our basics. We're going to create another event log. In this case, we're just using the PowerShell native command called write event log. In here, you provided your application or your log name. You provided your source, a type, which we're doing as a default information, and an event ID. This can be arbitrary because we're putting it in a source that we created with that default event message file, which whatever event ID you provide, it just publishes the message, not that boilerplate that we saw when there's a mismatch between the event log message file and the actual event ID. And then we just write this out and PowerShell creates the entry for us. So if we look, we have this entry. It's our sources BHIS 1337 is our event ID, and we have our message that says join our Discord community. There is one hopefully obvious issue here that just immediately stands out as like this doesn't quite align with everything. And that's the fact that there's another option for a write event log, and it's the category. In most cases, not all, the category is just going to be none. There will be some other ones, like when you clear an event log, the actual category, task category says like event log or something like that. It actually gives you some context and stuff, but in most cases it's none. So if we give the same PowerShell command as previously and we just pass it the dash category parameter with 0, it creates a new entry here, and we can see that it says none, just blends in just a little bit better. Operationally, it doesn't really provide you anything different than what we had before. So the last kind of thing I wanted to look at, or I thought it was the last thing that I wanted to look at, was what kind of size restrictions or limitations there are within event log entries and things like that. There are some considerations that we'll talk about this shortly about just the number of event logs that you can have before they rotate and things like that. But I was like, is there a limitation to just how much stuff, how much data can I put into a log? And so I started looking around. Microsoft's got multiple references on it. And it says, Microsoft told me that the maximum for at least a message was 31,839 bytes. And I thought this to be true. I made a mistake up until 3 nights ago. I'm like, I wonder if that's actually valid. Because I never tested the assumption. And let's be honest, Microsoft's documentation's never wrong, right? Yeah, it turns out that even Microsoft doesn't know what its limitations is. Playing around with a lot of stuff and sending a bunch of random data within PowerShell command, the PowerShell command write event log, it won't take anything over 32,766 bytes or characters. And I'm like, oh, that's significantly more, but that's cool. So I tried a few things. And turns out the magic number, at least in the Windows 11 environment, I don't know if there's been some change between like Windows 10, 11 or something like that. But for me, I could get a maximum message size of 32,730 characters, which is like, that's a lot of characters. But one of the reasons that this became important was because at the point in time in my research, we're probably mid-May or something like that. Not too long after I started this, the great guys at Infosec actually released a toolkit called Sharp Event Persist. It effectively is doing the same thing that we're talking about. It's designed to be, it's actually 2 .NET assemblies, one for loading the payload into the event logs, and the second for being able to retrieve that and inject that into the running process. I think this came out like June 15th or something like that. But what I found very interesting was that they were putting their entire payload in the body of the message effectively. As you can see from this is a screenshot taken directly from their GitHub repository. I highly encourage you go check those out. Go check that out. But as you can see in this message, you have just a bunch of hexadecimal, essentially a string literal, which I thought was interesting because the first thing I kind of thought about was like, couldn't you possibly just filter your event logs for something that has 0 punctuation? Because all of the event logs, at least that I have found, either ends with a period or something like that. This stands out to me as like kind of a red flag. Now, here again, you've got to be looking at these event logs, which is part of the problem. And you've got to know where to look and how to look. And this is kind of the cat and mouse game that we play within Red and Blue Team. But anyway, you also notice that they have a source of Cobalt. Out of the box, their tool will, I believe, create a source of Cobalt or persistence. I think it's now persistent. And so that will, if somebody's running that in your environment, you will get an IOC right off the bat from seeing that. But you can provide a user provided source and things like that. So just be aware of that. So that's all cool, but if I'm caught off guard by them putting the payloads that they're using in the message file, that means there's probably somewhere, in my opinion, that's better for us to store them in. And that means that there's more to come. And that's the fact that out of the box, event log supports binary data, and the fact that we can pass binary data at creation time and have it stored in the Windows event log entries. And this is what the threat actor that Kaspersky identified back in February that they were doing. Now, they were encrypting their binary payloads. We're not doing that here, but as you can see, we have binary data as part of the details of this event. This is a random one, 8224 from VSS. Pretty default. You should see this on most everybody, most of your Windows systems. No big deal, but it just gives us like, hey, here's a second place that we can potentially put data. This is, as I said, what the threat actor did. So this is the approach that I took versus putting in the message. It's one kind of layer deep if you're going through event viewer to find it, but it doesn't necessarily provide you any more security or obfuscation as far as being detected, because it's pretty trivial to parse event logs for the binary data. So by taking the same command that we did earlier in PowerShell, we can create a byte array of our binary data, and then we pass that with the -raw data parameter. It will then include that, append that to the entry, and we can see in the detail, we have our binary string here, as well as the actual data that says, thank you for attending. And that's how simple it is to put raw binary data into a Windows event log. How much data can be stored? Well, this is what was interesting. I couldn't find a clear-cut number when I was researching. And so I just went to a PowerShell loop and just started stuffing random chunks of data until I could figure out where it would crash. It wouldn't tolerate anymore. And it turns out that it's 61,440 bytes or 60 kilobytes, which is substantially larger than the message file, which I thought was also interesting. So if you're looking at a place where it's like, okay, I don't want to maybe create as many event logs, it makes a lot more sense to put your payloads in the binary data versus the message. That might be one of those things that you want to do, but there's also nothing stopping you, as long as you build the logic in appropriately, that you can store your payloads split across those two areas and different things like that. But 60 kilobytes of binary data will successfully go into an event log entry, which is pretty awesome. So now we're starting to really get towards the offensive side of things and where we're headed, and the fact that we're talking about storing a payload in Windows event logs that we can then later retrieve and execute. We're effectively taking and splitting I say we're splitting the lock and the key. That's probably not the best analogy, but by having the payload separate from whatever your injection, your execution method is, this can help get around some detections, because in most cases, in the instance of persistence, you're going to have to drop something to disk somewhere. And by not having an actual malicious payload on disk, it's when I say on disk, within your actual executable, your DLL or anything like that, you may be able to bypass some detections and stuff. So what I had to do was I needed to just not being a programmer or anything like that, hacked together just a simple proof of concept that I could inject a payload. We already knew how to do that through PowerShell. I was like, all right, now I need to be able to pull that data out. I need to retrieve that data so that I can eventually execute it down the road. And so here we have a PowerShell script. I'm going to link to a GitHub repository at the end of this. All the code is here, the PowerShell scripts and stuff. I'm not a programmer. It's really bad. It works, but don't expect too many additional use cases. So here we can see in the in the actual code that we're defining our variables. The biggest thing is that we're passing the payload as a hex literal string, and then we are splitting that up into the appropriate byte chunks in a byte array, and then injecting that as the raw data parameter. And then we pretty much reverse that operation. To be able to retrieve that, we use the get event log commandlet, and to identify where that log is, we're passing it again the log name, the source, the instance ID, and in this example, we're just pulling the latest entry to see that hey, there's our payload, and in the event log or event viewer, you can see that our payload is the same. So now I've soups to nuts. I've been able to say, okay, I have an effective method for injecting a payload into the event logs, and now I can retrieve that. So that's always fun, but the end goal was always for me to for this to be a .NET assembly and not rely on PowerShell or anything like that. So the next step was to take the PowerShell capabilities and convert it over to .NET to effectively do the same thing. And so on the left side of the screen, you'll see some of the very crass C# code that basically will go and retrieve the payload that we've put in from the event logs and then print it to the screen. You will notice I have key management service highlighted here, and this is the point in time where I actually switched from using BHIS as our application as the log, BHIS as the source, and just going to key management service directly with a source of KMS request. And the reason that I did this up into this point in the research, it was just kind of trial and error. But once I wanted to start replicating what the threat actor had done more closely, they were using key management services with a source of KMS request, which a user can write to. And so that's why you're going to see this switch. But it ultimately doesn't mean much. And so with that code, then the next thing, and actually this is the incorrect screenshot. I apologize. It effectively does the same thing. It gives us our payload, pulls it out of the event logs, and I can show you that in a demonstration next. So having been able to do that, successfully retrieve with our .NET assembly, I was like, the next thing is to actually do injection, which is I'm not a malware developer. I'm not an implant developer or anything like that. I basically stole this code, not stole it. I borrowed this code from a former colleague of mine, and it's worked reliably for me. So by making a few changes, specifically we're importing the kernel 32 DLL, and then we're at the lower section, we're doing our actual payload injection down below. We're able to then start to piece this thing together. So by running this compiled executable, you can see here that it found it. It's 24 bytes long, and it tries to execute it, and we get a memory violation. And I'm going, what the heck? And I'm like, oh yeah, duh. I literally just passed it a hex literal string. It's not executable code or anything like that. So, all right, we've got at least proof of concept that we should have something. So the next step is to turn to the world's greatest proof of concept utility that Microsoft created for us, and that is to try to pop calc. So to do this, I, like most everybody else, use MSF Venom to generate a calc.exe, output it as a hex string. We then put that hex string into our PowerShell script to inject it into the event logs. The event log or the PowerShell script then makes sure that it can read successfully from there. And here we have the event viewer verifying that our shell code is in fact in the key management service log successfully. And then when we execute that again, We still get an access violation, which I haven't actually took the time to trace down, but we see that calc.exe pops up. And with that, we're now getting somewhere. So let's switch over from the slides, and we're going to attempt to go live on demos. So I don't know if you guys have made all the necessary sacrifices to the demo deities of your choice, but hopefully we have. So we're going to first, we're going to RDP into a Windows 11 Pro host. I appreciate whoever just made the sacrifice in Discord.
Noah got your back.
Nice. All right, so we're connected to our Windows VM. So the first thing I want to do is to walk through the execution of just calc.exe, keep it kind of simple. We use MS Venom. We'll output this just to a file. Give it a, hopefully it won't take too long. Luckily, we're doing really good on time. So, and now it's being really slow. There we go. All right, so we have our calc. And so let's do and we'll just copy this to our clipboard so that I can, well, let's first look inside our event viewer. And I will probably, if I remember correctly, I have to zoom in so that you guys can see it because it's pretty small, I believe. Does take the event viewer a little bit to do the expansion. All right. I'll increase this a little bit so everybody can see it. Hopefully, we are in the key management service. There's no event logs. There's no entries that we need to actually be concerned with. So we jump over here to PowerShell. Jump into this retrieve. PowerShell, and we should be able to paste our payload. It's there. It's just a hex little string. And then if we run this, it should do the injection, and then it should loop back and actually pull the payload and convert it back to a string. And we can see that it looks correct. Looking correct is half the battle. And if we refresh, I'll open this up so it's a little bit easier. We can zoom in a little bit and see that we have our binary data. They both in Word form and in the actual byte form successfully stored in the event log. So we get back to 100% here. And let's open up terminal. And just so I am a local administrator on this box, but we're currently just operating in a user, a non-elevated context. Not that really matters because we're in a event log that can be read and written to from any user. So I think if we run BHIS1, we can see this is where we just successfully retrieving the payload with .NET. So this was that first test case where the screenshot was incorrect, and I do apologize for that. If we go to BHIS2, which actually contains the execution method or the injection, we should get it and wait for it. And we have calc.exe. Thank you for attending this webcast. No, I'm just kidding. We're going to go a little bit further from this, but we can see that we do have the basis of execution working, but we obviously haven't done anything cool. No offense to the developers that have worked hard on calc.exe. So we will clear out the event logs just so that we're not contaminating this particular log. and we will generate a new payload, get a little bit more greedy, we'll say. So we'll clear this off. Let's go see what I have here. Anybody want to see my interpreter? Cool. Nobody could answer me. I don't have much feedback. So we're going to do my interpreter. This will take. So there's a question. I quickly see EMV. So BHIS 1, BHIS 2. These are the .NET assemblies that I showed the code for in the GitHub repository that's referenced in the blog post, as well as I also have one for BSides Atlanta. There are versions of that code and the executables that you can just copy over. Understand, this actually leads to a good point, is the fact that in the context that we're operating, we've already established initial access on a system. This is not an initial access vector or anything like that. Now you could use part of this in conjunction with initial access, such as soon as your maldoc or something like that lands on the system, you could go ahead and inject the payload into the event logs for persistence. But fundamentally, you're going to have some means of executing. And ideally, this would be done through Cobalt, like something like Cobalt Strike, through execute assembly or something like that, where you're not actually dropping this executable to disk. But for proof of concept demonstration purposes, we just put the payloads or the injectors directly on the host. So thanks for asking that question. So we have here our interpreter, and let's see, we need to change this. All right. And so you'll see the sizes on this interpreter, I think, is 392 kilobytes. It's very, very large. And so we have to do something slightly different than what we did previously. And it's just effectively, we need to split up the shellcode into chunks so that we can create multiple event log entries that contain a chunk of that shellcode. Kaspersky, the threat actor they identified, was using 8 kilobit chunks. We're going to use 8 kilobit chunks, well, just to replicate that, but it's really arbitrary. You can basically go from 2 bytes because 2 characters, because we're using a hex little string. You have to essentially double everything, all the way up to the 61,440 or whatever bytes, that the maximum binary data that it will hold. So. That is incorrect. I ran into this issue yesterday, so give me 1 second. The issue is that it's not actually a binary file. And so using XXD, it tries to render as its binary and mutates the actual payload. That looks significantly better. So everything else is effectively the same here. We will clear this out. Just and so I'm using PowerShell here. You can use .NET. There's a lot of different ways to do this. This is just kind of the approach I took for being able to showcase this. But the sky's the limit. So here you can see that we're splitting the payload into 8192 byte chunks. And if we go into our event log now and refresh, we're going to see a bunch. I'll just open one. I think you guys trust me at this point. Probably shouldn't, but I try to be a trustworthy guy. And you can see here, let me zoom in just so everybody, you can see that we have, this is going to be the last bit of our payload, but it is there safely. And so just for context, we do have a interpreter payload on disk. And so that we're making sure that there's no tomfoolery going on, we will make sure that Defender is enabled. real-time protection. Real-time protection is enabled, cloud delivered protection. The only thing that is turned off is auto sample submission. And I also, just for context, let's do this because it shouldn't take but just a second. This was fully updated just a little bit ago. So about an hour and a half ago. Hopefully there's no updates. We'll see. But I'm not too worried about updates actually breaking this. Give that just a second. All right, so we're good. We're fully updated. Defender's on. Let's rock and roll. All right, so before we can do that, we do need to set up our listener. Since we are going interpreter, and I believe we used reverse TCP. So one thing to note that I got bit early on this is we are using a stageless payload. And the reason why we're using a stageless payload is because in almost all cases, while we're not talking about bypassing or evading defender or anything like that, the staged interpreter payloads are so signatured. As soon as execution happens and then that network call out happens, it's gonna eat the executable. It's just the nature of the way Defender works. You're definitely gonna have a lot better luck with a stageless payload. And so that's why we're using it. The unfortunate side to stageless payloads is your payload size, as you know, grow considerably. And so that's just something to be aware of. And that's the kind of justification for us doing it this way. So we'll use multi-handler. We'll set our payload to Windows x64 interpreter. Come on, tab completion. And then reverse HTTP. Did I say HTTP or TCP? I don't even remember. TCP. Set lhost to E0. And our payload was set to 8888, our port. Run. So we have this. We have our payload successfully in the event logs, and I'm going to quickly bump the size up. Did not mean to do that. Why is the size not increasing? All right. Jason, is the font size okay on this, or do I need to crank it up just a little bit?
Not great, but I think we can all tell what's happening.
All right, I don't remember where it's at. Here we go. We'll go big. That should be better. All right, so now if we do BHIS 3, which the only difference between 2 and 3 is the fact that 2 was only pulling the first entry, so index 0 effectively, whereas BHIS 3 will loop through all of the event logs, or all the log entries in KMS, or key management service, and then pull the payloads from those. So fingers crossed, we execute this. It finds it in 49 event logs. We see that the payload size looks correct, and it immediately terminated. And Defender caught it. Awesome. So this is one of those things that this is literally the second time Defender has caught that, and it ain't my executable. So this is going to make the rest of this fun. But if we jump back over here, we can see that it did close. So we're going to try a couple of other things. So let's do a set payload Windows x64 reverse HTTPS. Try that. Show options. We go ahead and run that. We'll come over here and we'll generate a new payload. dismiss. And let me see if I can get, because it did. Oh, that's rough. So it did eat our file. I don't want to, for the purpose of, this isn't an evasion talk, and so I don't want to explicitly allow Defender to ignore that file. So we're gonna take a slightly different approach. We're gonna go ahead and clear out these logs so that we have a fresh location. We have our payload generated, and then so we'll send this to our clipboard. Right, we have that all looks good. We can then send this. Okay, so we'll see if this works. I hope it does. Defender might alert on this too, and if it does, that'll be unfortunate, but it doesn't really necessarily change the context. So from a persistence perspective, the idea is that we want to have something that can automatically run, that we can automate, that will give us a callback and stuff. Luckily for us, Windows has been very gracious to provide us a couple of mechanisms that we can leverage for that. And one of those is specifically in OneDrive, that there is a scheduled task that runs the executable OneDrive standalone updater that's located in App Data Local Microsoft OneDrive. And it runs that pretty much on a daily basis. And because it's in App Data, it's user writable. We can replace that file, that executable, with one of our own and have our persistence that way. I already have that set up. So we will see if this works. All right, I am going to get this set up here just so you guys can see it. We'll zoom in just a little bit for context. Go up here. Taking a while. So here we can see this OneDrive standalone update task. There's also this OneDrive reporting task. It actually calls the same executable. And so if we click into this and we go to actions, you can see that it's actually calling this OneDrive standalone updater.exe. So I am going to zoom out, fingers crossed. And we're just going to manually run this. This is going to typically runs, like I said, scheduled about every day, but we're just going to simulate this. So we're going to hit run. And it didn't look like anything fired off. Why not?
Someone on Zoom is saying you copied wrong payload.
I copied the wrong payload?
That's what the chat message says.
All right. Yeah, let's check that. Thank you. So payload, MSF payload. No, that should be the right one. Unless, let me make sure. They're saying I have the, oh. All right. So it looks right, but I will never.
Another suggestion is an extra quote at the end of the line.
That might be an issue. No, it looks like it's encapsulated correctly. So the issue is it looks like the actual executable. We'll save that. We'll clear out the logs one more time. I do have a video of this working, so we've got a just a couple more minutes. So,
And Tim, one of the things I like whenever a demo doesn't always go right is that sometimes it's not going to go right for the people trying this for the first time. Like it's not 100% success rate all the time.
All right. Let's do a refresh. Just make sure our payload's there. All right. That looks good. Let's make sure that the file is still in place. Defender might have already eaten it because it's an exact copy of BHIS 3. Logo. OneDrive. Nope, it is there. And it looks like maybe, nope, I'm not sure why it's not executing. Awesome. That is unfortunate. All right, so let me see if I can pull, see if I can pull another copy over real quick. Where is it? I don't know if this will work through VMware Tools and RDP, but we'll see.
I just imagine you're going to be thinking about this for weeks.
Oh, I'm terrified at the moment, so don't worry about it.
No worries. You're doing great.
Yeah. All right. It's not wanting to copy. So let's just actually log into the VM natively. Let it catch up with me for a second. All right. So we have our file. I'm just going to execute it from here. See if, hey, okay. All right. This is what Defender caught it again. All right. So that's not going to work. Unfortunately, like I said, I do have a video of this working with Cobalt Strike. I'm not, for time purposes, I don't want to, I'm not going to try it with Cobalt Strike, but it does. Up until this morning, this stuff was all working just fine. But this happened. So we'll walk through this video real quick. Essentially the same thing. This is from B-Sides Atlanta just 2 weeks ago. We'll log into the system. We execute the OneDrive standalone updater, and then we're able to get our Cobalt Strike beacon, and it's good to go. We're successful. Real-time protection's enabled. Automatic sample submission is disabled. And then we will eventually run this. We can see that it executes, and then we get our interactive shell, our beacon. We can then set our sleep mask, and then it unfortunately, because we're not using any kind of profile or anything like that, we have to wait our default 60 seconds. From then, we'll be able to run get UID. Actually, I can just fast forward it. Ain't nobody got time for that. All right. And then we get that, and then we can get our system info. And we have our beacon. Now, that being said, there is one caveat to this whole thing. I think the Cobalt Strike would work if I didn't, if Defender hadn't eaten my executable. but that's really evasion is not the point of this. That's an up for you guys to do. There is one point that unfortunately I couldn't show you in this demo is if you attempted any kind of post exploitation after you get a successful session or a beacon, Defender will catch it. So if you, let's say you're a local administrator and you're a interpreter and you run hash dump, you're going to kill your session. And the reason why is we're not doing actually any kind of invasion in memory, bypassing AMC or any stuff like that. So this is really just a jumping off point for this type of technique. And so in conclusion, we got a massive 2 minutes. I ask again, what is lurking inside your event logs? Most likely nothing. But I'm not going to, I won't say that there won't be down the road. This isn't something that's been heavily talked about or published. And I'm going to continue researching this and evolving it. I already know where part 2 and part 3 is headed with this. And so I ask those questions, what's there, what's happening. We got to have at least one meme here. So blue teamers, you use event logs to figure out what happened. I use them to make it happen. And thank you guys for tuning in. And if I will try to go back and ask any or answer any questions, you guys, I'm going to hang around for a little bit. I'm also will be on Discord on, you can either DM me or preferably just reach out to me on open chat. That way we can keep that dialogue going back and forth. And that way anybody else can see the answers that are there.
You did it, Tim. All right. Hey, good job. Also, you lived out the fear most people have about presenting or giving a presentation. You lived it out right in front of us. And so I hope that from now on, all webcasts will be uphill from here.
So when I did this at B-Sides, I actually started the entire presentation with the demos, which was it was right after lunch. I'm like, let's come out with a bang. Luckily, that went a lot smoother than it went today, but that's okay. This thing's happened. I've got a couple ideas that I know as to what's going on. And so actually stay tuned. I'm going to troubleshoot this and I will send out I'll jump on Discord or something like that and go, here was the exact problems, because this has worked very consistently with Meterpreter as well as PowerShell. There are a few caveats to it using stage versus stageless payloads and things like that. But yeah. This is fun. Thank you guys for tuning in, and let's go through some questions.
Well, let's go ahead and wrap, and then we'll do some questions. So we want to say thank you so much for joining us here on this Black Hills Information Security webcast today. We had Tim with us talking about Windows event logs, red teams. So thank you so much for doing that. Everyone in my office right now is whispering around me, but that's fine. So thank you. If you'd ever need a red team threat hunt, pen test, or anything like that, you know where to find us. And this is the end of the actual webcast. And so, Tim, we're in post-show banter. Deb, you can come in now instead of just trying to be quiet off to the side. Not really well.
It might be me.
It's Deb. So, Tim.
You did great. You did
So what we're doing right now is we're doing post-show banter. If you want to stick around, Tim's going to do some Q&A for a few minutes, and then we'll be done for the day. We like to have a nice hour long, because if you see more than an hour on YouTube, you're like, ugh, gross, more than an hour. But all right, Tim, is that Windows device enrolled in MD4E EDR?
No, this is it's just a bog standard Windows 11 Pro VM with the default commercial Microsoft Defender. Here again, this isn't an invasion talk or anything like that. So going against any specific endpoint or anything is kind of an exercise for you as the listeners to take this technique and go beyond that. This is the baseline proof of concept. But like I said, I do have a part 2 and a part 3 that would get more into how to use this operationally, and not just in the proof of concept stage.
Someone said, why not use .bat?
.bat for what? Specifically for the execution? Here again, this is a proof of concept. You can do whatever. It's more about just putting it out there as this approach is. The real issue that we have here is, and I touched on this at B-Sides Atlanta. The problem is not that we can store payloads in event logs, because you can store them in text files and stuff. They may get caught doing that way or something like that. The real issue and how you stop this is you stop execution. If you can stop execution, the event logs don't matter. This is just a mechanism that we can use that is it's a blind spot for Defender. It's a blind spot for most EDRs. And so it's something that we can use. There's other techniques that you can leverage to do the exact same thing. This was just one that I found was really interesting, and I wanted to take a stab at recreating it.
Is the interpreter shellcode not going to be larger than the available space for the event log?
So yes. And so in this case, the interpreter event log or the interpreter shellcode was approximately 392 kilobytes. And that's why we had to split it up into 8 kilobyte chunks across, I forgot what the actual total was, but many event logs. And that's why you were seeing multiple entries. And each one was just appended with the subsequent 8 kilobyte chunks.
How does AV handle these logs?
They don't.
Okay.
And that's the biggest thing and why this technique was successful in the wild was that nothing's scanning them, and there's not a big initiative or justification for scanning them. And the reason why I move back that the logs themselves are not the problem. It's execution. If you cannot stop execution, I can own you 12 different ways to Sunday. The event logs are irrelevant. This is just a mechanism that we have. As far as scanning event logs, that's going to be it's going to be kind of like AV signatures. It's going to be very, very difficult because what I'm showing here is I'm putting taking a monolithic payload, chunking it up into sequential event log entries. And that's something that you could kind of write an alert for or stuff like that. But what I don't show is what I'm actually doing in the real world, where I'm spreading my payload across multiple logs, multiple sources, multiple event entries, possibly with time delays and things like that. As a blue team, good luck. Like, you've got to go back and piece that together, and just alerting on, you could do some simple things like, oh, hey, here's this is a large number of a large binary data. That would be something that you could definitely alert on. But it's going to be a manual process. As far as I know, there's no tools that are actually looking at doing this. Hopefully, by the end of this year, I'll finish my actual companion piece to this, which is essentially a situational awareness tool that will, as a red teamer, it will identify key spots for us to inject payloads into. Like, it'll scan your system, it'll look at your existing logs, things for, like, we have to account for log rotation and things like that. It'll count for logs that are and event IDs that are typically sent up to a SIM or things like that. But blue teamers will also be able to use the tool in the exact same manner. They go like, hey, here's where a red team would probably recommend putting payloads. Why don't we go look there and stuff? But it's a manual process. I'm doing it through PowerShell right now. Hoping to get that wrapped up by the end of the year, just to help aid in this. I can't really predict the future of how common or prevalent this is going to be in the wild, but it is just something to be on the radar. At the end of the day, you got to stop execution.
Yeah, I was just thinking of the first blue teamer who comes across this is like, hey,
it has been done at BHIS, and nobody has figured it out yet.
Yeah, I think that's what I want to wrap with today is our job as security testers is to figure out all the ways that security can be bypassed and see if we can bypass security that way. But when you're looking at the thing that you're doing here, how much of this is a team effort? How much of this is just you being creative and curious? So take me through, you came up with this, but then what happened?
So what happened was, obviously John sent the article and I kind of jumped on it and started doing some of the proof of concepts. And I got it. It actually worked so well right out of the gate that I had to go to Geoff Thayer and go, my code works and I don't know why. Mm-hmm. And because it was too simple. And it really was. So the first ever payload beyond calc that I did was just MS Venom, just a shell reverse TCP. And it worked. And I'm like, this is awesome. I don't understand why this is. And that was kind of the driving force of okay, let's figure out where the limitations kind of exist in this. And so then I shopped it around with a bunch of the awesome colleagues at BHIS going like, does anybody have any input? Caitlin and Noah, I got on calls with them. I'm like, I don't know what to do with this. Like, can you give me some help from a blue team perspective of what do we do to like detect this, alert on this and stuff? Because like I'm grasping at straws of like little IOCs, but they're nothing that is really indicative of what's actually taking place. And so it was awesome to get that feedback and collaboration, and then just kept kind of trying it and ramping it up. I actually had to do a complete code rewrite for an actual engagement because early on I was just using small stage payloads in some cases, or things like Metasploit's shell reverse TCP, which are very small, could fit into one event log, no problem. But in practical application, we were dealing with much larger payloads. And so I had to both rewrite how I actually injected the logs, and then how the actual injector itself worked in terms of staying alive and spinning off some new threads and stuff because of the well, actually it's public now, so we're using Kyle Avery's Ace Loader, which is awesome. He did a presentation on it at DEF CON, and so it out of the box doesn't like to work with loaders that the main thread exits, and so we had to do some retooling of that and got some input from Joff again, and it was awesome.
So I'll finish with this. Like whenever someone gets to Black Hills, they come to work here and we're like, yeah, you want to give a webcast? And there's like normally a hesitation of like, no, like there's this, I don't know, imposter syndrome of like, I've been watching them, I don't want to be on one. But you've been here a year now. You just did your first webcast. What would you say to somebody who may like join an organization and they're hesitant to give a webcast, even though you had a demo not go as planned today? What's your advice to someone who would want to share their knowledge but's a little concerned?
Well, so it's never not going to be terrifying. If you're nervous, if you're apprehensive, it's just because you care and you're passionate about it and you want to deliver the best possible talk and stuff. I have been in talks where everything has gone horribly wrong and they still ended up being some of the best talks. Because the content was relevant and things like that. But in pen testing and stuff like that, it'd be just like, we don't use smoke and mirrors. Like we're just trying to be as transparent as possible. Here's what worked. Here's what didn't. Oh, that blew up in my face. That's really disappointing. This is recorded on YouTube for all time's sake. I might have to copyright something real quick so I can copy strike this or something. I don't know. No, but it is what it is. But one of the things that somebody on this webcast told me at one point in time, or something in a presentation was effectively like, we need to share our knowledge, and we shouldn't keep it to ourselves because just because we're nervous or anything like that, because it's for the betterment of the community and things like that. And we don't want to take away someone's opportunity to learn just because I'm not willing to share. And it's a tough thing to get over. There's definitely a lot of nerves. It's for me, this is a lot harder than like B-sides, because in B-sides, I can see people, there's interactions, facial expressions. You can see when things go really bad. You can see things when go really good. You can hear the, kind of stuff like that. Here, it's just like, with Discord, like I see Discord flowing, and stuff, but it's like, I can't focus on that and stuff like that. So it's definitely different, but I encourage anybody, BHIS included, all of we've got such a wonderful staff that has just so much knowledge. And there's really, the thing about this community is that what we take for granted is the fact that I know it, so everybody else knows it. That's just not true. There are things that I know, and that I one of my biggest pleasures of working at BHIS is actually being able to work with other people. And they're like, I'm stuck on this, or what do you? I was like, oh, have you tried this, or do you know about this? And we jump down that rabbit hole together. And they now have another tool in their arsenal. They have another approach, or they may just have more understanding, which gives them the confidence to repeat that steps down the line. And that's how we grow as individuals, and that's how we grow as a company.
Thanks, Tim. And thanks, everyone. If you liked today, please join us for future. If you were like, Interesting. No, you were fine. Join us in the future. Tim, you did a great job. Well done with your first Black Hills Information Security webcast. We'll see y'all next time. Thank you so much. Ryan, kill it with fire. Kill it. Kill it, Ryan.
Kill it.
Ryan, kill it.
We're still alive.
Come on, man.